Alright, let me make a quick little video here about how to find the matrix representation of the dual numbers. Dual numbers have the form x plus epsilon y, where x and y are real numbers, epsilon squared is 0. As a point set, this is R2. Our notation here is that the number 1 is E1 and the number epsilon is E2. Now, to find the matrix representation of Z in an algebra where E1 is being the identity of the algebra and multiplication is juxtaposition, the matrix representation is just given by Z times E2, Z times En. And that is going to give you the matrix representation of Z. In that case, all right, we need that the identity is E1. I'll give you an example where the identity is not E2 and not E1, probably in class Monday. But anyway, moving on. So here's how we actually do it for the dual numbers. The matrix representation, representing x plus epsilon y is x plus epsilon y, then x plus epsilon y times E2. But again, E2 is epsilon, so I do that. Multiply that out, x epsilon, y epsilon squared, but epsilon squared is 0. So lo and behold, it's this matrix, x, y, 0x, which is what I have in the notes. So those are the details which I didn't write explicitly in the example on dual numbers, but I have written such details for the complex number example. Now, you have a homework problem about the three hyperbolic numbers x plus yj plus zj squared, where x, y, z are real numbers, j cubed is 1. And I've asked you to verify that the matrix representative of that is what it is. The way you do that is to calculate, just like I just did for the dual numbers, the matrix corresponding. We put the number first, the number times j, the number times j squared. That is giving me the matrix which represents the number. It's a 3 by 3 matrix, and here I'm calling the number Pac-Man. And this is with respect to the notation E1 is 1, E2 is j, E3 is j squared. That's my assumption. That's our default notation for three hyperbolic numbers. That's our choice of basis, if you will. And again, here's another. So x plus jy plus zj squared is another notation for x, y, z in this world. Anyway, I hope that helps you with that problem in the mission. So thanks.